Hello and welcome to the Rocket Lab launch coverage for today's mission, our 30-second Electron launch and our next recovery mission that we have aptly named Catch Me If You Can. You can see the Electron rocket on your screen as it stands ready for the countdown to liftoff from Rocket Lab's Pad B at Launch Complex 1 in Mahia, New Zealand. My name is Muriel Baker and I will be with you through today's launch and recovery attempt from Rocket Lab's Mission Control Center. We are several hours into launch operations now, and about 20 minutes or so to launch right at the top of today's launch window with the T0 set for 06:27 New Zealand local time or 15:27 UTC. We have had a clean run through the count and remain on track to launch right on time today. And today's launch includes a single satellite headed to low Earth orbit for the Swedish National Space Agency. I'll tell you more about the MATS science research mission shortly. But excitingly, today is the day we make our next attempt at catching Electron with a helicopter as it returns from space. For those of you unfamiliar with our recovery program, we are evolving Electron into the world's first reusable orbital small rocket by using a helicopter to catch Electron's first stage as it descends back to Earth after launch. Right now, our recovery helicopter is stationed over the Pacific Ocean off New Zealand's east coast, waiting for Electron's launch. And from Mission Control, the pilots will receive the signal from our recovery team to move in and tail the returning rocket as it descends under parachute before they make an attempt to hook onto Electron's parachute line, secure the rocket underneath the helicopter, and transport it back to land. We will have cameras on board Electron's first stage feeding us live footage of today's recovery attempt. There is also a live camera feed from the helicopter that we'll share, but we do expect some dropouts in the video footage from both the rocket and the helicopter during today's operations. If the feed freezes, don't panic, we'll bring it back up as quickly as possible, and we will stay with you on this program to bring you updates from Mission Control. We are still obviously in the test phase of our recovery program, so everything learned today is a useful step toward the ultimate goal of catching and reflying Electron. In case the catch is missed today, we have prepared to recover it from the ocean, like we have done on previous recovery missions, so we'll bring you updates on those operations too. Using a helicopter to catch a falling rocket is obviously not as simple as it sounds. It's a complex operation that requires precision, perfect timing, and for our helicopter pilots, complete calm under pressure and a steady hand. But here's how they'll do it.
Electron is one of the world's most innovative rockets. Since its first launch in 2017, it's pushed the boundaries with 3D printed engines, electric turbopumps, and new carbon composite technology to become one of the most frequently launched rockets every year. And what's faster than building more rockets? Reusing the ones you already have. Which is why we're evolving Electron into the world's first reusable small rocket. So we can launch, catch, and launch again. Here's how we'll do it. About an hour before liftoff, we dispatch our helicopter, a Sikorsky S-92, to around 160 nautical miles out to sea, where it will remain on station in the capture zone, where Electron will descend after launch. Around 2.5 minutes after Electron lifts off, more than 80 kilometers above Earth, the rocket's first and second stages separate. Electron's second stage carries on to orbit with the payload, while the first stage, or booster, begins the return journey to Earth. Tiny reaction control thrusters reorient the booster to the correct angle of attack to slice through Earth's dense atmosphere. Electron's booster will be falling to Earth at top speeds of 8,300 kilometers an hour and a temperature peak of close to 2,400 degrees Celsius. About 5 minutes after Electron's return journey began, at 13 kilometers above Earth, a drogue parachute is released to help slow things down. Less than a minute later, the larger main parachute is deployed from the first stage as well, bringing Electron's speed down from thousands of kilometers an hour to just 36 kilometers an hour. Arriving into the capture zone at sea, where our helicopter is waiting, our pilot begins to shadow the returning rocket, waiting until the rocket is below to follow from above and match the rocket's descent. Slowly, the pilot will bring the capture hook closer and closer to the parachute line. The hook then captures the line and secures Electron's first stage underneath the helicopter. From there, our helicopter pilot brings Electron's booster back to land, where it is returned to our nearby launch site or rocket factory to be assessed, refurbished, and soon, potentially relaunched.
Our motivation for making Electron a reusable rocket is to lower manufacturing costs and create more launch opportunities for small satellite missions, like the one on board Electron today for the Swedish National Space Agency through OHB Sweden. Called MATS, the satellite's acronym stands for Mesospheric Air Glow Aerosol Tomography and Spectroscopy, a bit of a mouthful, and its mission is to investigate atmospheric waves above Earth to better understand how our planet's upper layer influences wind and weather patterns here on the ground. A bit like how waves in the ocean are generated in different ways, can travel and strengthen over long distances and influence water conditions at the beach, waves in the atmosphere can link together different parts of our climate system, and MATS is on a mission to find out more. Here's more about the satellite and the teams behind it.
Under senare år har vi lärt oss väldigt mycket att atmosfären, olika delar av klimatsystemet, hänger ihop på olika sätt. Att någonting som sker på ett ställe påverkar vad som sker på ett annat ställe. Och samtidigt har vi lärt oss att vågor som går genom lufthavet, det är de som gör den här kopplingen i många fall. Hur kopplar vågor ihop olika delar av klimatsystemet? Det är det som man ska ta reda på.
Att vi får reda på hur vågorna ser ut där uppe kan göra att vi får bättre information om hur vi ska lägga in effekterna av dem i klimatmodeller. Så på det viset kan kunskap om de här vågorna högt uppe i atmosfären bidra till att vi får bättre klimatmodeller och bättre kunskap om framtidens klimat.
Basically, we're taking pictures of the Earth's atmosphere, and we're using infrared and ultraviolet cameras to image atmospheric features such as high altitude clouds.
Det som kanske är mest unikt är att vi kommer göra tomografi av atmosfären. Det är ungefär samma sak som man gör när man gör en hjärnscan. Att man tar flera bilder, så här, tvådimensionella bilder av hjärnan, och så sätter man ihop det till en tredimensionell bild av tumören då. Men vi kommer göra det på atmosfären istället. Det har inte gjorts på det här viset förut, och det ställer en del krav på upplösning och sånt på teleskopet. MATS kommer ge oss ett unikt datasätt som vi hoppas helt enkelt att kommer användas av forskare i hela världen. Och det är inte alltid helt lätt att svara på exakta slutresultaten på de här vidare studierna. För det är sådana saker som man kanske inte ens vet nu. Som ozonhålet visste man inte om. Man kanske upptäcker någonting som är annat liknande det.
We are thrilled to welcome MATS and the Swedish National Space Agency for launch from LC1 today. We are coming up on the go, no-go poll for today's mission. Run from the Mission Control Centre by our launch director, we will get a status update from each of the operators and whether they are tracking to time for launch. Let's listen in.
And to all operators, this is LD on mission code. We are proceeding now with a go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Recon.
Recon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
Recovery.
Recovery is go.
LD sub.
LD sub is go.
The go, no-go sequence is complete. We are currently T-minus 11 minutes and 24 seconds in counting. We go for the terminal count at T-minus 10 minutes, and from this time on, the freewheel hold procedure is in effect.
So there you have it. That is confirmation from Mission Control that all systems are healthy and we will be proceeding with the remainder of the count. The T0 liftoff time remained 06:27 New Zealand local time or 15:27 UTC. Let's take a closer look now at the Electron rocket on the pad and some of the tweaks we've made to enable today's recovery attempt. Electron is a two-stage to orbit launch vehicle that stands 18 metres tall. Starting from the bottom, that's where 9 of its 3D printed Rutherford engines are located. Together, they power the first stage, the section of the rocket from the engines up to the red band you see on your screen there that indicates where the first stage is connected to the second stage. It's this first stage of Electron that we'll be attempting to recover during today's mission, while the rest of the rocket, that second stage and the kick stage carrying the payload, travels on to low Earth orbit. Now, around that interstage area, there is a reaction control system that includes tiny thrusters on the rocket's exterior that help reposition the first stage as it descends back to Earth. Packaged inside the top of the first stage also are 2 parachutes to slow down the first stage for the recovery attempt, the smaller drogue parachute that deploys first, and the larger main parachute that our recovery helicopter will attempt to connect with. Rounding off Electron at the top, we have the second stage with a 10th Rutherford engine. We optimise with a large exhaust nozzle for the conditions of space. And connected to the second stage is the rocket's third stage, which we call the kick stage, which has the MATS satellite attached on top. Now, this kick stage has its own little engine called the Curie engine, which is used to circularise the orbit it's deployed to before the payload is deployed itself, marking the end of the mission. Now, Electron might be considered a small rocket, but snagging a 1-ton object falling from the sky is a big ask for a helicopter, and one of the challenges for our recovery team was finding one large enough to safely catch it and bring it back to land. Our Sikorsky S-92 helicopter, though, is up to the task. It's one of the few helicopters large and reliable enough to catch a rocket mid-air. It's capable of lifting up to 5 times the weight of Electron's first stage. The Sikorsky S-92 global fleet has accumulated more than 2 million flight hours and completed more than 91,000 search and rescue missions. Its other missions have included coastal and border control, emergency response, disaster relief, and head of state transportation, and now catching rockets in the air. The helicopter flies with a crew of 3, a pilot, a co-pilot, and a rocket spotter. To complete its rocket-catching mission, the Sikorsky S-92 has been modified to include extended-range fuel tanks for open ocean flights, a capture hook on a long line to catch the parachute line attached to Electron's booster, pilot assists for recovery operations, including a bubble window to better see the returning rocket, and displays with position and direction information for the intercept, along with some other minor modifications. To practice our rocket catching skills, we have carried out several helicopter tests and achieved some major mission milestones on our road to reusability. Here is the timeline of our recovery operations to date.
Catch Me If You Can is our latest mission in our extensive test program to evolve Electron into the world's first reusable small rocket. Here's what we've accomplished on our road to reusability. To reuse Electron, first, we need it back in good condition. The first stage needs to make its way to Earth through incredibly high speeds and temperatures. And in late 2019, we proved that it could, with our first telemetry-guided re-entry through the atmosphere after the launch of our 10th Electron mission. We introduced new recovery hardware for the first time, including guidance and navigation hardware, S-band telemetry and onboard flight computer systems, and a reaction control system to position the first stage on the correct angle to protect the Rutherford engines and survive its journey through the atmosphere back to Earth. From reaction control system to actual recovered stages, we moved quickly to bring Electron back to the factory after launch. Twice in 6 months, we released the parachute to guide Electron's first stage for controlled water landings after launch. Our recovery ship brought them back from the ocean, and how they fared informed how we'd proceed with the next step. Next, we proved our Rutherford engines are up to the task of reflight when we successfully fired a recovered engine for the first time. The refurbished engine passed all of the same rigorous acceptance tests we perform for every launch engine, including 200 seconds of engine fire and multiple restarts. Data shows the engine performed to the same standard of a newly built Rutherford engine, producing full thrust of 21 kilonewtons within 1,000 milliseconds of ignition. Being able to refly Electron without too much rework is the aim of the game. Before Electron took to the skies for recovery, we took it over the ocean with a helicopter as one of our many mid-air capture tests. These tests involve dropping an Electron test article from a helicopter over open ocean before a parachute was deployed from the stage. Then, a second helicopter closed in and caught it mid-air at around 5,000 feet, using a hook to snag the parachute's drogue line and bring it back to land. With these tests, we proved mid-air capture was possible. Then, it was on to the real thing. To catch a rocket as it falls from space, you need a big bird. The helicopter for the job is a customized Sikorsky S-92, a large twin-engine helicopter big enough to fly the distance to the capture zone and resilient enough to transport a rocket underneath it. In May 2022, we used it to make a mid-air capture of Electron with a helicopter for the first time. After launching to space, Electron's first stage returned to Earth under a parachute. At 6,500 feet, our Sikorsky shadowed the stage's descent and used a hook on a long line to catch it by the parachute line, a highly complex operation that demands extreme precision. Successfully demonstrating on the very first attempt that we can do what we set out to do, we'll be bringing back the helicopter to catch Electron in the air again for our next recovery mission.
Our recovery team are very eager to get back this latest Electron and assess its condition after launch. The first stage will be inspected inch by inch to discover how well its components survived the return to Earth and what could be a candidate for reflight testing. We are now heading into the final countdown to liftoff of Catch Me If You Can with just over 2 minutes on the clock. The launch range is clear, Electron and the MAT satellite are healthy, and our recovery team is ready and in position for launch and recovery. Shortly, Electron's flight computer will take over and run down the clock as the final pre-launch milestones are reached. Then it's on to the 10-second countdown to liftoff for Catch Me If You Can. Let's hand it over now to Mission Control.
AVPs are on internal power. Vehicles fully on internal power.
AFTS is green and enabled for flight.
Oxaload is complete. System is in recirculation. Anti-geyser is disabled.
Stage 1, Stage 2, rest for flight.
High flow engine purge enabled. Deluge is activated.
And we are T-minus 19 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off.
Beginning to pitch over.
Stage 1 propulsion nominal.
Rocket Lab Launch Complex 1 and is on its way to space carrying the MAT satellite. Our rocket recovery attempt is also now officially underway. Coming up on supersonic speeds, Electron will be travelling faster than the speed of sound as it approaches its first mission milestone, maximum aerodynamic pressure. Electron's Rutherford engines will throttle down slightly to pass this pressure point, and once cleared, we should hear the call from mission control that the rocket has passed max Q.
Vehicle is supersonic. Approaching max Q. And vehicle is cleared max Q.
Stage 1
there we go.
propulsion
As expected,
holding
Electron has cleared that first milestone and is continuing nominally. Electron's Rutherford engines will now throttle back up as the mission continues on, and all looks nominal for propulsion there, with that beautiful view of LC1 below. In about a minute, we will reach the point in the launch when Electron separates itself. Known as stage separation, the Rutherford engines on the first stage will shut down for the rocket to safely separate before the engine on the second stage can fire up and carry on with the mission. The calls for these events will proceed as MECO, or main engine cutoff, stage separation, and then second stage engine start. And here is when our recovery team begin their countdown to the helicopter catch as the first stage will begin its journey back to Earth. Standing by now, though, for those calls.
"15 seconds to staging.
Entered burnout detect mode.
MECO confirm.
Stage separation successful.
Stage 2 ignition.
And as you can see, we have had a successful MECO and stage separation, followed by the engine on Electron's second stage igniting successfully. You can see that by the red hot glow of the Rutherford nozzle on your screen there. For recovery, the first stage is now beginning its journey back home. The trajectories for both stages are looking good so far. The next mission event will be fairing separation on the second stage, coming up in just a few moments.
Fairing jettison succeeded.
In fact, actually, there it goes. Electron's fairing has been deployed, and Matt is now exposed to space while remaining attached to the rocket's second stage as it continues on the path to orbit. The vehicle is now traveling at a speed of more than 8,000 kilometers an hour with an altitude of 129 kilometers. Meanwhile, Electron's first stage continues its migration over the South Pacific Ocean. When it separated from the second stage, it was traveling at such high speed that its trajectory continued upward from the momentum. But in another minute or so, it is expected to reach the highest point of that arc, otherwise known as the apogee, and from there, descend toward the capture zone, where our recovery helicopter is ready and on standby to proceed. We should hear the call out from Mission Control, and we'll keep up that first stage camera view on your left for as long as we can.
Stage 2 propulsion, still nominal.
The telemetry data for both stages is on your screen and coming back nice and clear, showing the progress of the first stage. We're just starting to see that arc back downward as it heads towards Earth, whereas on the right, that telemetry line is heading upward as it should as Electron's second stage continues to orbit. This camera view on Electron's first stage tells us a lot about how well the booster is faring on its way back to Earth, because with the stage hitting speeds of up to 8 times the speed of sound, we may actually see a glow at the bottom, and that would be from plasma, which forms during the descent as a condition of a very fast atmospheric re-entry.
Stage 2 guidance still nominal, 200 seconds remaining.
Electron's second stage, though, continuing to orbit with propulsion firing hot and nominal. Fairly soon, Electron, though, will need another power source for Rutherford's electric pump cycle. We use batteries for this, but like all batteries, they run out of juice after extended use. So Electron performs an action called the battery hot swap, where it swaps over to a new set mid-flight to keep the engine running for longer. Sometimes you can catch a glimpse of these battery packs falling away. So let's listen in for the call out from Mission Control and watch our screen for those battery packs.
Engine is starting to throttle down.
Hot swap successful. Battery jettison confirmed.
There's that call from Mission Control. Battery hot swap is confirmed. The cameras are a little bit late, but we can confirm those batteries did swap over as planned.
Stage 2 propulsion.
Motor pressed.
HVP discharge holding nominal.
Stage 2 guidance in terminal, 25 seconds to go.
Seco, confirm.
Stage 3 separation confirmed.
Nominal transfer orbit.
There we go. That's the call for SECO or second engine cutoff, and stage separation has been confirmed. That means Matt's and Electron's kick stage have commenced their first pass around Earth in its initial orbit. Around 40 minutes into this coasting phase, the kick stage's engine will light up to move it into a circular orbit position where payload deployment will be performed. We'll come back to that final mission action, but while Matt's takes a cruise, we are full screen with the camera view from the helicopter as our pilots move in for the mid-air rocket catch attempt. Between the main parachute deployment and the time it would take Electron to reach the ocean, our pilots have about 10 minutes only to complete the catch. And catching a rocket with a helicopter is a tricky operation because within that time pressure, our pilots need to control the Sikorsky, balance the swing of the hook underneath while it's attached to the helicopter's line, hook it precisely to Electron's parachute line, and then secure the rocket beneath them for the journey back home. Now, right now, the mission is on track to do all of those things, but just in case, we are prepared with a nearby ship should we need to fish Electron out of the water instead today. To make sure you catch Electron gliding into view, keep your eye on the edge of the screen where we expect to see it today. Just a note on the soft water splashdown I mentioned before, if we did that today, that would not be a failure for our recovery program. In fact, we've performed several of them across our missions to date, and most recently, we were able to refire a Rutherford engine that had been returned from the ocean. Right now, though, we have an anxious wait with our fingers crossed until we might see Electron again on our screen. Our rocket spotter on board the helicopter has a few more tools to help them with this task, obviously. They've got this view and the view out the window, of course, but also those display screens that plot theirs and Electron's positions with telemetry and where they might intersect for that catch attempt. While the Sikorsky has been positioned out here over the ocean during mission operations, it's got a range of 950 kilometers. That means it can safely capture and return Electron to land following a successful catch. And now that Electron's first stage is empty of propellant, it will weigh approximately a ton in dry weight. Our Sikorsky, though, is rated to be able to carry up to 5 times that, so we've got good margins for a catch and carry back to land. our Rocket Lab team back here at Mission Control, who are watching as anxiously as I am to see that Electron glide into view. Whether they've touched this mission themselves or have supported across some other functions through the business, everyone is just as invested in seeing Electron brought back to the factory. The recovery team themselves are stationed in various support locations. Some are in the Mission Control Centre, others are on our recovery vessel on the ocean near the capture zone, and of course we have the helicopter pilots as part of that catch attempt too. For those of you just tuning in, a quick reminder that we have had a successful first part of the mission, and the MATS satellite, as you can see on your right-hand side with that graphic, is in a transfer orbit on its way to its final destination. Hello again from Mission Control. We have just had an update from the pilots, and unfortunately it looks like we are not going to bring Electron home dry today, but we do have the backup option of an ocean splashdown. We'll bring you updates on that ocean operation in the hours to come, but for now we are going to leave you with the views of Electron's kick stage as it moves through its transfer orbit on the way to payload deployment for MATS. We'll be back for payload deployment at around T plus 50 minutes. See you then. Welcome back to the webcast of Rocket Lab's 30-second Electron mission, Catch Me If You Can. Our mission to attempt to recover Electron's first stage after launch while delivering the MATS satellite to low Earth orbit for the Swedish National Space Agency. Launch today included a successful on-time liftoff at 06:27 New Zealand local time or 17:27 UTC. After passing through max Q, Electron completed a clean first and second stage separation. And while the second stage continued on its journey, Electron's first stage began its journey back to Earth. And so far, a flawless primary mission for today's launch for OHB Sweden and the National Space Agency in Sweden too. But unfortunately, though, we are not bringing Electron home dry on this mission due to some telemetry loss from the rocket's first stage during re-entry. As standard procedure for safety, we pull the helicopter out of the recovery zone if this happens, so we couldn't attempt a catch today. But this is what test programs are all about, pushing hardware and systems to their limit and iterating. Fortunately, though, we do have an ocean recovery as a backup option, as we've successfully demonstrated several times now, and we can confirm that Electron completed a safe splashdown. So the recovery vessel will be moving in to collect the stage very soon. Taking what we've learnt today and pushing toward the ultimate goal of launch, catch and repeat, we will be back with the helicopter for another mid-air capture attempt. In the meantime, though, our mission to deploy the MATS satellite for the Swedish National Space Agency has continued on to its destination in low Earth orbit. The kick stage has completed its first pass in an elliptical orbit of Earth, and we're now waiting for its Curie engine to ignite and position the kick stage in sun-synchronous orbit at a 585-kilometre altitude, where we will deploy the MATS payload. Those events should happen in quick succession after the kick stage's Curie lights up. Let's bring up this animated view of that payload deployment and listen in to mission control for the callouts.
Payload deployment confirmed.
And there you have it, short and sweet. MATS has been successfully deployed by Electron on this mission, and that completes our 30-second Electron launch, officially bringing the count of satellites deployed by Rocket Lab to 152. Congratulations and thank you to OHB Sweden and to the Swedish National Space Agency for choosing Electron for your mission. We're going to end the broadcast here, but keep an eye on Rocket Lab's Facebook, Twitter and Instagram pages for updates on Electron's journey back. My name is Muriel Baker. Thank you so much for joining us. This is Rocket Lab Mission Control, signing off.